I'm making an example here about linear regression and how to write an equation using regression. This is a made-up data set, but I'm going to use the labeling on this that the X values in my chart are the number of years since 2000 and the Y values in my chart are the number of sales in thousands. So for an example, it should be similar to examples that you would see in real data that you might be able to use linear regression on. Now, when I look at the data values that have been plotted in this table, I can see that they do form almost a straight line. So I use linear regression if the data is maybe not perfectly linear, where they have the exact same slope between any 2 points, but where it's almost perfectly linear, where it's very close to linear. So how regression works, I'm going to show you first how I remember how to do it, and then I'll clean it up and write the actual equation. The first thing I remember is that if I want to write the equation of a line, the equation of the line is y equals mx plus b. That's just the standard form for the equation of a line, y equals mx plus b. Now that's not regression, but that's how I start regression. Then regression is going to be an equation that is for approximate data, where it's almost perfectly aligned. So I use the tilde key, the approximate symbol, and then I have to tell the calculator here where to find the data. So the chart up here has labeling x1 and y1, so I tell it to find x in the x1 list, and I tell it to find y in the y1 list. That's what I need to do. So for linear regression, I need to enter y1 approximately mx1 plus b, and the regression equation is created and graphed. So what does this tell us? If I scroll down and look at this regression equation, I see the statistics section, the residual section, and the parameter section. I'm mostly concerned with the statistics section and the parameter section, so I'm going to talk about those two things. First of all, the statistics section. The R value is your correlation coefficient, and it tells you how good the model is. How well does a regression model fit the data? And this value is between 0 and 1. The R squared value is between 0 and 1. And the closer it is to 1, the better your model fits the data. So with an R value of 0.997 or an R squared value of 0.994, those are very close to 1. So this model should be very close to the data points. It should be a very good fit. Now for the parameters. The parameters give me the actual numbers for M and for B in my line. So I can write the equation. Let's see, this is number of sales. So I'm going to call my equation S for sales equals M, this is my number for M, copy, times years. So I'll use T for years. I'm writing y equals mx plus b. I'm just not using the letters x and y because we're putting some letters in context. If you wanted to use x and y, that's fine. I'll write it with x and y in a moment. Plus b, this number. Okay. So I could have written that equation with x and y if you feel more comfortable using the letters x and y. Sometimes we will keep those traditional variables. Other times we'll use variables that work in context of the situation. Okay. Now we often round these to 3 places instead of using that whole value, so I'm going to round these as well. So if I round this to 3 values, that 2 is followed by an 8, so I'm going to round the third decimal place to a 3. And then this 2 is followed by a 3, so I'm going to keep it a 2 when I round. So we'll keep that at 2 when we round, and our 2 here followed by an 8 will round to a 3. So this would be the equation written in standard form, and I get that equation from doing regression and identifying the parameters, plugging those in for M and B respectively.